All right, so now that you've tried these exercises, let's look at the solutions here. So we've got the height of a ball t seconds after it is thrown, given by the output of this function. Let's find the times where the ball reaches a height of 135 feet. So the height here is the output of this. When it says a height of 135 feet, that's this. So what we want to do is know what is the time. So we're going to leave the t as a variable and then solve this equation. So there's two ways you could do it. I'm going to do it what I think is maybe a slightly quicker way. I'm going to say 135 equals this version of the equation, negative 16 times t minus 1 quantity squared plus 144. And so just plugging, and I could also have done it with the other version of the equation by doing 135 equals that one, and that would work just fine. You could still use the quadratic formula here, but I don't know, I like doing it this way. Practice the basic equation solving methods, subtract 144 from both sides, which gives you negative 9 equals negative 16 times t minus 1 quantity squared. Divide both sides by negative 16. Oh, 9/16, that's my birthday, September 16th. And then we're going to have t minus 1 squared. Take the square root of both sides. The square, you can do the square root of 9 and the square root of 16 separately. That will give you plus or minus 3 in the top, and then the square root of 16 is 4. So then we're going to add 1 to both sides. So that means we've got, let's see, t could either be 1 plus 3/4, which comes out to be 1.75 if you want it as a decimal, or you'll get t equals 1 minus 3/4. So we have the plus or minus there. And 1 minus 3/4 is 0.25 seconds. So yeah, there are two different times, 0.25 seconds and 1.75 seconds, where the ball is at that height of 135 feet. Okay, so yeah, once on the way up and then another time on the way down. All right, let's look at exercise 3, finding x and y intercepts. This is an important concept that comes up a lot. So first of all, let's get x-intercepts. So remember, on the x-axis is where y equals 0. So if you want to find x-intercepts, you're plugging in y equals 0. On the y-axis is where x is 0. So we're going to plug in x equals 0 for those. Let's start with the y-intercepts. That's actually a little quicker. So we're going to replace the x with 0. So we're going to do 0 squared minus 3 times 0 minus 10. So that's just going to be y equals negative 10. So that means this has the point 0, negative 10. Oops. That's your y-intercept. Okay, now the x-intercepts are going to be where y is 0. So I'm going to replace the 0 here. Instead of plugging in x equals 0, we're plugging in y equals 0. And then we have x squared minus 3x minus 10. So this is a quadratic equation we have to solve to see what values of x make this true. So if you can factor this, that works. factoring is pretty quick, or you could use the quadratic formula, or even better, you could do both and make sure you get the same answer both ways. And if that's what you did, then I would give you a high five, but I don't want to give you the coronavirus or get it from you. So I'll give you a high five over the internet. There. Okay, so anyways, I'm just going to do it by factoring because I believe this is factorable. Even though a lot of things are not factorable, this one you can factor into x minus 5 times x plus 2. Hopefully that's the same thing you got by doing the quadratic formula. If that's how you did it, it should be x equals 5. That's what would make this part equal to 0. The value of x that would make this other factor equal to 0 would be x equals negative 2. So those are the x-intercepts. We've got 5, 0, and negative 2, 0. Okay, so then let's look at this one. If we're finding the y-intercepts, we're going to plug in x equals 0, and you know if you do that, you're just going to get negative 30. You're going to get 0 plus 0 minus 30. So that's that. Now for the x-intercepts, let's plug in y equals 0. And what I notice here is that everything on the right side is divisible by 3. So you can make this easier on yourself by just going ahead and dividing everything by 3. 0 over 3 is just 0. 3x squared over 3 is x squared. 18x over 3 is 6x. Negative 30 over 3 is minus 10. And so, is this factorable? Can I find two numbers that multiply to make negative 10 and add up to 6? No, that's not going to be factorable. So we're going to have to use the quadratic formula here to say x is going to be negative 6 plus or minus the square root of 6 squared minus 4 times 1 times negative 10, all divided by 2. Let's work this out. 6 squared is 36. Negative 4 times negative 10 is plus 40. And 36 plus 40 is going to be 76. And you could just leave it like that, I guess. We could say the x-intercepts are negative 6 plus the square root of 76 over 2, comma 0. And the other x-intercept is going to be negative 6 minus the square root of 76 over 2, comma 0. Or you could do it with a calculator. Let's do that real quick. All right, so we get 1.36 and negative 7.36. All right, so those are your x-intercepts of that. And it never hurts to check. I'm going to check on Desmos really quick here. Here's the first one, x squared minus 3x minus 10. Where are the values of x that make it equal to 0? We got negative 2 and 5. That's what I said. Okay. And then the other one is y equals 3x squared plus 18x minus 30. And let's see what we got. Negative 1.359 and 7.359. So that agrees with what I got here. Wait. Positive 7.359 and negative 1.36. Uh-oh. Did I make a mistake? Oh, I made a mistake here checking your answer. Okay, so that was supposed to be plus that. Okay, that was a plus 18x, which now... There. Okay, now it checks. Sounds good. So now let's look at exercise 4. So we're going to use the discriminant to say whether the equation has 1 or 2 or no solutions. So let's see, we're going to find b squared minus 4ac, and c, is it positive, is it 0, is it negative, is the idea here. So let's see, the b squared minus 4ac here is going to be 7 squared minus 4 times 2 times 3. So that's going to be 49 minus 24, which is positive. That's going to be, what, 25. That's greater than 0. So this has 2 solutions. If you want to check it, you could always just graph y equals 2x squared plus 7x plus 3. And yeah, it crosses the x-axis at 2 spots. So this has 2 solutions. And then with this one, the b squared minus 4ac is going to be 4 squared is your b, minus 4 times a times c. The a is 4. And the c is 1, so this is going to be 4 times 1 here. So let's see, this is going to be 16 minus 16, and that is equal to 0. So what does this say? If your discriminant is equal to 0, then your equation has 1 solution. And a quick check here will give you y equals 4x squared plus 4x plus 1. Yeah, and it just crosses the x-axis, whoops, at that 1 spot, negative 0.5. So it has 1 solution, and it is negative 0.5. Okay, so here is a very tricky problem. So a gardener wishes to double the area of her 4 feet by 6 feet rectangular garden. She wishes to add a strip of uniform width to all 4 sides. So let's start by drawing a little picture of it. So let's say this is the garden, which starts off 4 feet on one side and 6 feet on this side. So it looks about like that. And then the strip of uniform width would mean another bit where this is the same width all around. And I didn't draw it quite with uniform width, but we're close. So this distance all the way around, we're going to pretend it's the same. And that right there is your strip of uniform width. And so the question is, how wide should the strip be so that the total area is twice as much as it was before? So the way I drew it, it looks like it's probably not quite big enough because it doesn't look like it has twice as much area. So let's figure out a few things first. The old area of the smaller bit of the garden was 4 feet times 6 feet gives you 24 feet squared, 24 square feet. If she wants to double it after adding the strip, it should be doubled would mean 2 times 24, which would be 48 square feet. So that's the goal, is to make this become 48 square feet. And if we want to know how wide should the strip be, that's the goal here, let's call that width W. Good to come up with names of the thing you're asked to find, so let's call it W. And we need to find what is W so that the new area is 48 feet squared. So if you know what W is, how would you find the new area? Well, let's see, what is the new length and height of the garden? So let's see, this is 6 feet, but then there's an extra W over here. Draw a little dotted line there. So we got W over here and W over here plus 6. So that new width is now going to be 6 plus 2W. The new height, make a little room for that here. That new height is going to be, well, it was 4, but then there's an extra W on the top and an extra W here. So that new width is going to be 4 plus 2W. So the new area is, you could write it as 48 feet squared. You could also write this new area as 4 plus 2W times 6 plus 2W, the new length times the new total width. And that's what we want to make equal to 48 feet squared. Alright, so this is the equation we've got to solve. Let's FOIL this out. 4 times 6 is 24. 2W times 6 is 12W. 2W times 4 is plus 8W. 2W times 2W is plus 4W squared. And that should be equal to 48. And if you want to use a quadratic formula, you might want to subtract the 48 from both sides, because you need a 0 on one side to use the quadratic formula. So let's see. I'm going to write this in the sort of standard order with a 4W squared first. And then we have 12W plus 8W is plus 20W. And then 24 minus 48 is negative 24. And I notice everything has a factor of 4 here, so it always makes things easier if you factor out your common factors. Six, so 4 times W squared is 4W squared. 4 times 5W is 20W, and 4 times negative 6 is negative 24. And this is factorable. I can just write, you could use the quadratic formula with A equals 1, B equals 5, C equals 6. That's fine. But I think I can do this a little bit more quickly by factoring it into W plus 6 times W minus 1. So what are the values of W that make this equal to 0 here? Let's see. W equals negative 6 will make this part 0. Or W equals 1 will make this part 0. Now, if W is negative 6, that doesn't really make sense. It is a solution of this equation. I don't think I made any mistakes here, but you can't have a strip of garden that is negative 6 feet wide. You can have a strip of garden that's 1 foot wide. So this is the solution that makes sense here. So let's just check really quick that if you make this be 1, we're going to have now, let's see, what is this going to look like? If that's 1, this is going to be 4 plus 1 plus 1 is going to be 6. Now we're going to be 6 on this side, and then 6 plus 1 is going to be 8 on this side. So 6 times 8 is going to be 48 feet squared. So yeah, this is how wide her strip should be. All right. If you did this one, you're doing great. Keep it up. If you didn't, that's okay. It's a tricky one. But the more difficult things you try, the stronger you'll get. So I hope you try some challenge problems in the future. Even if you tried this one and didn't get it, you're still getting stronger, even if you're not getting the answer every time. All right. I'll talk to you again in section 4.1, I think, is what's coming up. Have a good day.